Hello and welcome back. We're back into chapter 12, which is on matrices. We already did addition and subtraction, so today we're going to do multiplication. And multiplication, we have two different kinds. We have scalar multiplication, which is just like multiplying by a number, so it's more like distributing a number through to a matrix. But we also have matrix multiplication, where you're going to multiply a matrix by a matrix. So here's our essential question: how are multiplying matrices different from adding and subtracting? And then our objectives are to model matrices using scalar multiplication and then using matrix multiplication. Alright, for scalar multiplication, a real number factor such as 3 is a scalar. So that just means a coefficient, a number. To multiply, you just take your matrix and then you distribute it through to everything inside the matrix. So here we go. Given A and B, what is 4A, 3B, and 4A plus 3B? So here's A and B. So to find 4A, we just take and we distribute 4 through to everything. And remember, this is multiplication, so 4 times 2, 4 times 8, 4 times negative 3, 4 times negative 1, 4 times 5, 4 times 2. So our matrix 4A would be 8, 32, negative 12, negative 4, 20, and 8. Pretty simple. You just multiply the number through. 3b, we take 3 and multiply it to everything inside our matrix. So 3 times negative 1 is negative 3, 0, 15, 0, 9, negative 6. Now if we were to take and add 4a plus 3b, we just have to ask ourselves, are these matrices the same dimensions? They are, so we just add up the numbers in the same spots. 8 plus negative 3 makes 5. 32 plus 0 makes 32. Negative 12 and 15 makes 3. Negative 4 and 0 is negative 4. 20 and 9 is 29. And 8 and negative 6 is 2. There you go. Pretty simple, right? Not too complicated. Alright, for solving, what is the solution of 2x plus 3 times our matrix 2, negative 1, 3, 4 equals 8, 5, 11, 0? Okay, so what we're going to do is first we're going to multiply that scalar through to the matrix and then just solve it like an algebraic problem. We're going to add a matrix. Let's see, that's 6, negative 3, 9, 12 equals 8, 5, 11, 0. Now, if we were to solve using algebra, what's our goal? To get x by itself. So first we need to get rid of this matrix. How do we get rid of a matrix? Well, how do we get rid of just like a number 2? We would subtract 2 from the other side. So what we're going to do is we're going to subtract this matrix. 6, negative 3, 9, 12. So this is like distributing a negative through. So what we're actually doing is adding negative 6, positive 3, negative 9, negative 12 to the other side. So we get 2x equals 8 minus 6 is 2, 5 plus 3 is 8, 11 minus 9 is 2, 0 minus 12 is negative 12. Okay, now how would we get x by itself? We would divide by 2, or since we're not dividing matrices, we're multiplying. You can multiply times 1/2. That means the same thing. So we're going to distribute a 1/2 through inside the matrix. And that makes 2 divided by 2 is 1, 8 divided by 2 is 4, 2 divided by 2 is 1, negative 12 divided by 2 is negative 6. So this is our answer right here. If we were to plug this into x and then add this to it, we would get this. And you can even double check your work, which, I highly recommend. Okay. Now we're on to matrix multiplication. So in a matrix, in order to multiply, it's a little bit confusing, so I'll just go kind of slow. You multiply this first column by this first row. And you take the first one times the first one, and then you add the second one times the second one. And that goes in this first box here. In the second box, let me erase this. In the second box, or the second part, you take your first column or your first row and you multiply it times your second column. So you take the first one times the first one plus the second one times the second one. And then you do that again on the bottom. Bottom times side, bottom times side. So for matrix multiplication, you're multiplying across on the first one to down on the second one. Alright, so let's go ahead and do this one. What is A times B? So let's see, I have 2, -3, 1, 0. I'm multiplying that times -1, 0, 3, 4. Okay, so we're going to multiply. I'm going to have to use lots of colors, so try and follow along. I'm multiplying the top row by the first column. So 2 times -1 is 2 times -1 plus 1 times 0. Okay, now in my second one, I'm going to take that first row again times the second column. So I have 2 times 3 plus 1 times 4. In the third one, I take the bottom and I multiply it by the first one. So I have -3 times -1 plus 0 times 0. And then my last one, I'm taking the bottom, multiplying it to the side. -3 times 3 plus 0 times 4. Okay, now what I have to do is I need to now just combine these. 2 times -1 is -2 plus 0. So my first one is -2. This is 6 plus 4, that makes 10. This is 3 plus 0, which is 3. This is -9 plus 0, which is -9. So that is A times B. -2, 10, 3, -9. So remember, multiply sideways by up and down and add them together. That just tells you how to do it. Okay, now here we just need to do some practice. So we're going to do A times B and B times A, and then we're going to answer, is it commutative? So do we get the same thing if we multiply it both ways? So go ahead and pause your video, because I'm just going to write down the answers. So pause now. No, really, pause now. And then check your answers and see how you did. Okay, so when you multiplied A times B, you should have gotten -6, 0, -9, 11, and B times A is -3, 7, 6, 8. So these numbers are not the same, so you can tell that multiplication is not commutative with matrices. So you need to make sure you pay attention to which one goes first. Alright, and then to find the dimensions of a product matrix, if you have two matrices that are different sizes, you might still be able to multiply them. You just have to make sure that your across is the same as your up and down. Your across on your first one is the same as your up and down on the second one. And then when you multiply them, your different dimensions are going to be your new dimensions. So you can see that across on this one is 2 and down on this one is 2. So we can multiply these two. But your new dimensions for your new matrix are going to be 3 by 4 because you have 3 this way and you have 4 this way. So this is just a hint to help you when you're multiplying to know what your matrix should look like. Alright, so determining whether product matrices exist. So that's what I just said. The rows and columns must match. Okay, so let's decide if you can multiply A times B. Can you multiply row by column? Yes, you can. But can you multiply B times A? For B times A, we would take, come on, row by column. We have 1, 2, 3, 4 here, but only 3 here. So you cannot multiply b times a, but you can multiply a times b. Okay, so let's think about it. I'm just asking, can you multiply these? Can you multiply a times b times a times c times a, and b times c? Okay, I want you to talk about these with a partner. This is part of your lesson check, and then this is the second part of your lesson check. So I want you to do both these two slides. So do they exist or do they not exist? Discuss that. And then I also want you to use your matrices to do 3a minus 2b and find the solution of the second matrix. Alright, we're done. Hope you have a great day.